Sunshine is most intense at the equator where it's closest to the Earth. It's within these tropical regions that many of the world's most robust plant growth is found. Unfortunately, as we move away from the equatorial regions of our planet, the sun is not as consistent nor as intense for long enough periods to allow the same species plants to grow to the same size and quality that we see within the Earth's tropical regions. So unless you happen to have a backyard located on the equator, we have to effectively simulate those natural sunlight conditions indoors with the proper artificial lighting. In order to achieve the optimal lighting conditions for our indoor plants, we must have an understanding of both the quality as measured in PARs and the quantity of light that a particular lamp emits as our plants see it. Here we'll compare the relative intensity, PAR quality, of the light that our plants see as generated from a variety of different lamp types with identical data points and wavelength spectrums. By combining the energy efficiencies and custom blending of lamp phosphors, our EFDL broad spectrum lamps will emit white light while still providing peak UV and IR spectrums within the essential growth PAR, PPF, and YPPF ranges. When comparing indigo with triphosphor blends, the visible ranges between green, yellow, and orange reduce as the ultraviolet and infrared ranges expand. This creates less stress on the plants as there is a single lamp from vegetative through flowering and budding cycles. Now, please note that these charts don't represent our current spectrum. The new proprietary phosphor mix is improved over what is displayed here with a better balance and an added 5% bandwidth at 630 nanometer range for explosive growth and an improved finish while flowering. Conventional grow techniques have traditionally favored a dual approach to plant lighting, whereby metal halide UV light provides the cloning and vegetative spectrums with a later switch to high pressure sodium lamps, IR light, for the flowering and budding. Note this on the spectrum charts below. Standard triphosphor blends are the most widely used blends on the market today. Where these blends distinguish themselves is in the visible spectral ranges. These ranges are commonly referred to in Kelvin values. What is most interesting with the 4 standard triphosphor charts below is that how little variation there really is within the infrared side of the spectral wavelengths at 600 plus nanometers. Standard triphosphor blends will emit peak wavelengths within the visible green, yellow, and orange spectrums of 500 to 600 nanometer, and not emit broader PAR spectrums. On the other hand, indigo's broader infrared spectrums can accelerate growth rate, promote flowering, enhance the color of the fruit, stimulate healthy root growth, and not contribute or promote stem elongation as seen in standard triphosphor blends. The newest generation of indigo lights, the ProPAR series, is by far the best option for grow lighting available today. Superior results with a lot less energy, better health, explosive growth with a beautiful finish to flowers and fruits.